Now we're down to the final assembly, and I'm sure you've realized by now, either watching what I did or you're doing it yourself, and you've realized that you really have to be careful with what you're doing with that soldering iron and the solder and the heat. And as you solder connections that are close together, you need to go back in and make sure that they're all adequately separated. Now, if you want to be really tight about this, you could put heat shrink tubing on every single connection and then heat shrink it if you wanted to. I don't choose to do that. I just choose to pay attention and make sure that I go in with a pair of side cutters, little skinny ones like this, and trim off any excess between the terminals so there's no way that they can touch. Now the toggle switches, those solder lugs are really stiff. You can't hardly push them together. But on the push buttons, you've got 3 for the push button, then you've got the minus and the plus. Those can get squeezed and bent as you're closing the lid and moving the wires around, and you can flex some of those solder connections into other solder connections. So you got to be really careful what you're doing. Okay, so let's go into the final assembly procedure. I'm actually just going to put it on the camera and talk about it. Let's do it. Here we are with our finished product. There's only one other item you might put on this, and that is a strain relief right here where the leads, the fly-out leads, leave the enclosure. You could put a grommet or a strain relief right here. I typically put tie wraps on this side so you can't pull them through the hole and stress the connections, and I put tie wraps on the outside for the same purpose. So let's see what we did here since we were last here. Notice that the red, or the positive 24 volt DC coming from these bulkhead connectors, they were twisted together, and then the lead going over here to the toggle switch was twisted with those and then soldered. Now notice there's heat shrink tubing on here. Make sure that you slide this on to either this lead or this lead before you solder, because you can't add it afterwards. As a matter of fact, this black one right here, that was a mistake, and rather than take it apart, I just left it on there. So the red to the toggle power switch from the power adapter is now connected, and I did the same thing with the black. Now you could have done a terminal strip. You could have used double-sided tape and put a terminal strip down in the bottom of this box. And if you struggled with some of these connections, especially this common connection that has 3 wires under it, and this common positive that also has 3, you could have run these 2 conductors from your pilot light down here to the terminal switch, and from the toggle switch for the power switch down to here, and then ran back the commons. I tend not to do that. So I have everything connected here, and just to review what we did the black common on all of the push buttons from the in terminal on all 6. Then we also added in the black wire that comes over here, and we picked up the black wire from the pilot light. Then we did the blue wires. In other words, we have a pattern here of going from the inside connection on the push button switch to the top connection on the toggle switch. So we did the dozen blue wires. Then we went back and we did the red wires, picking up the red wire from the pilot light and from the output of the toggle switch. And then we did the output wires that go from the plus side of the LED through these basically white, and then there's one yellow wire. They go to the outputs on your controller. These conductors right here go from the center lugs on the toggle switches to the screw terminals on your controller for inputs. So to follow the path, you have 24 volts DC that comes in on either one of these bulkhead connectors. They're wired in parallel. That way you can plug in a power adapter to one of these and then jumper from here to something else. Because we do have an analog field device simulator that is a companion to this digital field device simulator. So 24 volts DC comes in through the toggle switch. If the switch is on, the light lights up, the pilot light, and we feed 24 volts DC to the common connector on each of those 6 push buttons. Then, coming through the normally closed and normally open contacts, we go to either side of a toggle switch and then out of the toggle switch into an input screw terminal. So the toggle switch determines which one of these 2 contacts we have selected. And then, of course, you have a minus side, which is the return. So that completes it right there. Now notice that I kept the outputs and the inputs separated with tie wraps, and I did the same thing down here. That's more for organizational purposes and handling. The next thing you have to do is you have to make a list of color codes. So if you started with the inputs, this is input 0. 5 is at the bottom. So blue, green, brown, gray with brown, brown with green, and pink with brown. Input 0, 1, 2, 3, 4, 5. Then we have yellow with brown, white with yellow, white with pink, white with green, white with gray, and just plain white. That's OUT00, or output 0, output 1, output 2, output 3, output 4, and output 5. That's simple. Digital field device simulator. Whether you buy this box from me and or these parts from me, you can build this exact device with all your parts in your box. You don't need a box like mine with all the printing and everything on it. That is nice and neat and tidy, but totally unnecessary. You don't have to use 16 millimeter switches and mini toggles. You can use selector switches instead of toggles, 2-position selector switches, and you can use the larger NEMA push buttons and lights. And the lights don't have to be inside of the push buttons. You could have a selector switch, push button, and then light. Because remember, this special circuitry that I've shown you how to do, you can, in this position, the switch is off, so you've selected the normally open. So if you push it, it goes closed. If you flip the switch up, then you've selected the normally closed. So it's on all the time, you push it and it goes off. So you can use selector switches in any single pole double throw push button, has normally open, normally closed, in any light. You could even use other voltage levels. So the circuitry is the same regardless of the components that you're using. And you don't have to have a power switch. I do that because I like to know if the box has power on it or not. And remember that this power is being supplied up to the controller, not necessarily for the controller, but you can do that. Because remember, you've got a red and a black wire coming out of here going up to your I/O module. You can jumper that red and black that's controlled by this power switch into the 24 volt DC supply terminals on your controller, and you can turn the whole thing on and off with this switch. As a matter of fact, the training units that I use in my live classes, that's exactly what I do. Now, if you buy this box, what comes with it is a document that has circuitry, some instructions, tells you where you can find these parts, roughly what they're going to cost, etc. And you can find your own parts. Not too long ago, I decided, since I have quite a few of these parts on hand and I know how to get them easily, that I'm going to sell a kit. Now the kit does not include the box. The box is separate. So rather than force somebody to buy the box and all the parts, or buy the parts and they don't want the parts, they just want the box, it's separate. Now what you will get if you buy the box is the box with no components whatsoever, but it's all machined and printed, and it comes with a document to explain where to get the parts. If you buy the parts, which is separate, you will get exactly what you see: 7 toggle switches, 6 LED backlit Form C momentary push buttons, 24 volt DC pilot light, and 2 bulkhead connectors. You won't get any wire, no solder, no tie wraps, just what you see. And I recommend using the multicolored wires from a length of cable. A lot of your electrical distributors sell multi-conductor cable by the foot. So you can walk in there and say, I need a cable of 22 gauge, stranded, multicolor, and I have to have at least 6 in, 6 out in power. So you need at least 14 conductors or more. If there's more, fine. You don't have to strip the sheathing off the cable. You can leave the sheathing intact and just peel it back enough to make your solder connections here and your connections on the other end to your controller. Well, thank you for attending this lecture series on building a digital field device simulator. Hopefully you clearly grasp the idea. You don't have to buy anything from us. You can buy your own parts, your own box. We just show you how to do it. We also do an analog field device simulator. And you see it's the same enclosure. It's just different machining and different printing. And this is mounted on a piece of ABS with pads, and it's portable between different training units. So what you have here is two analog outputs. So you have 0 to 10 volt meters, and these binding posts give you access to that voltage. So if coming out of your controller through analog outputs right here, you go to this meter and it's 5 volts, you can take this 5 volts and feed it to a variable frequency drive so you can see what your analog out is, and you can still extend that analog voltage out to the field. So you have 2 of those, you have 2 analog outputs and binding posts. They're field extendable. Now here you've got 4 toggle switches, and the toggle switches pick between 2 different things, obviously. The outside binding post and toggle switches, if you flip this toggle switch up, it connects this 0 to 10 volt signal with a potentiometer to a conductor going into your analog input. Same thing over here. If you flip it down, now you've connected these terminals into that same analog input. So you can pick between the potentiometer or your own analog input. Same thing on both sides. So you have 2 channels where you can use the 0 to 10 volt potentiometers, or you can flip the toggle switch down and pick your own analog input. These 2 in the middle are different in that the only thing that they do is this toggle switch toggles this terminal between 2 wires coming out of here. Some analog cards, like Compact Logic 1769 combo analog, you can wire up current or voltage. So this allows you to select between a voltage 0 to 10 volts connected here, or 0 to 20 connected here. I say 0 to 20, that could be 4 to 20. So this is kind of a cover-all analog field device simulator. I haven't done any videos on building one of these or where to find the parts. I really don't even know if it's worth it. We sell some, but we don't sell a whole lot. I don't know what the demand is out there. If I get a lot of requests for a video showing how to build one of these, it would be the same form as the series you just watched. I'll show you how to attach the parts, where to get them, and then we'll flip it over and do some soldering. This has a lot more parts in it, and it's more complex. This does not supply any current analog signals. It supplies 2 0 to 10 volt DC signals, and that's it. And you can read 2 0 to 10 volt outputs, analog outputs. So if you want 4 to 20, 0 to 20, you're going to have to attach it to these terminals from your own little signal generator. So I think that about wraps it up. Also, you see on the top here, I've got a jumper. Remember, we have 2 of those bulkhead connectors. I've got a jumper plugged in, so I can plug this right into my digital field device simulator sitting right next door. One other thing that I might throw up here, you can see an example of using this digital field device simulator, and this is for a Micro 820. And this is my catch-all training unit. I can do USB through this remote LCD, and it comes out RS-232 to feed up to here. And I have a toggle switch so I can pick between an RS-232 connection to my laptop or the USB, because you can't have both. This is just a little DIN rail mount breakout board, and notice that I'm connected to all of the terminals here, or rather I should say that this switch picks between these terminals and these terminals down here to feed into this RS-232 input. Thank you for paying attention, and good luck with your learning path. Thank you.